Good morning to everyone. Today we will learn about 11th standard chemistry, an important concept. So already we have learned about the periodic trends in chemistry. Okay, what are the periodic property? They are atomic radius, ionic radius, ionization energy, electron affinity, electronegativity. So already we have learned up to ionization energy, and now we will learn electron affinity. Okay. Electron affinity. So it is defined as the energy released when an electron is added to the valence shell of a neutral isolated gaseous atom in its ground state to form its anion. So it is defined as the energy released. Okay, it is defined as the energy released when an electron is added. When an electron is added to neutral isolated gaseous atom in its ground state to form anion. In its ground state to form anion. Neutral isolated gaseous atom in its ground state to form anion. It is expressed in kilojoule per mole. It is expressed in kilojoule per mole. Okay, it is expressed in kilojoule per mole. அதாவது ஒரு எலக்ட்ரானை ஆட் பண்ணும்போது ஒரு anion ஃபார்ம் ஆகும் இல்லையா. whenever an atom accepts an electron, it forms an anion. So on that time some energy is released, and that energy is known as electron affinity. So electron affinity is defined as the amount of energy released when an electron is added to the valence shell of an isolated neutral gaseous atom in its ground state to form anion. So கடைசி இருக்க செல் தான் என்னது valence shell or outermost shell. So whenever you are adding an electron, some energy is released. So whenever you are adding an electron, some energy is released. Okay, that energy is known as what? Electron affinity. For example, this atom, when you add one electron, so இந்த ஆட்டத்தோட ஒரு எலக்ட்ரான் நீங்கள் ஆட் பண்ணும்போது it forms anion plus what? Electron affinity, or this is nothing but the energy released. Okay, so to an atom when you add an electron, there will be release of energy with formation of anion. So ஒரு எலக்ட்ரான் ஆட் பண்ணும்போது எனர்ஜி ரிலீஸ் ஆகும், அதே நேரத்தில் ஒரு நெகட்டிவ் அயான் ஃபார்ம் ஆகிருக்கும். that is your electron affinity. Okay, so this is expressed in kilojoule per mole. Okay, variation of electron affinity in period. Okay, periodல electron affinity எப்படி இருக்கும்? So in period this electron affinity it increases. In period the electron affinity increases. Same reason தான், electrons are added to same shell. Okay, electrons are added to same shell. Okay, electrons are added to the same shell. So nuclear charge, okay, nuclear charge increases. So the distance between the nucleus and the outermost shell decreases, nuclear charge increases, size also decreases, as well as shielding effect decreases. Shielding or screening effect. Okay, shielding effect decreases. So what happens here? The electron affinity increases. So electron affinity increases. In group, the same reason you have to write, electrons are added to new shell. Electrons are added to new shell. Electrons are added to new shell. Okay, nuclear charge decreases. Why? Because the distance between the nucleus and the valence shell increases. Nucleusக்கு valence shellக்கு இடையில உள்ள distance அதிகமாகுது. அப்ப nuclear charge என்னாகும்? குறையும். Nuclear charge decreases. Shielding effect என்னாகும்? It will increase. ஏன்னா நிறைய shells add ஆகும்போது nucleusல இருக்க proton வந்து electrons பார்க்க முடியாது. So shielding effect increases. Okay, shielding effect increases. Shielding effect increases, and thereby the electron affinity EA in group what happens? It decreases. EA in group, electron affinity in group, it decreases. But there are some variation. For example, in beryllium and nitrogen, there is a anomalous property, or there is a difference. For example, this beryllium, what is the atomic number of beryllium? Hydrogen, helium, lithium, beryllium, atomic number 4, 1s2, 2s2, and this nitrogen, it is 5. Okay, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, 7. Okay, so 1s2, 2s2, 2p3. So here Sல வந்து 2 வைக்கலாம், 2 fill ஆயிட்டு, and in p orbital you can accommodate 6, but we are having 3. So already we told that whenever an orbital have half filled or completely filled electrons are completely filled, it will be stable. இப்போ இது ரெண்டும் stable இருக்கும்போது it is very difficult to add another electron to this beryllium and nitrogen. So this beryllium and nitrogen, there will be decrease in the electron affinity. So electron affinity decreases here. Okay, then as well as in group, for example this oxygen and fluorine, there will be decrease in electron affinity. Why? The same reason, because it has small size. With a small size irukum, 2p orbital is very compact. So idhula ulla 2p orbital vandu compact ah irukum. Compact na enna romba tight ah irukum. Appo it is very difficult to add another electron. அதோட இன்னொரு எலக்ட்ரானை ஆட் பண்ண முடியாது. அப்போ சல்ஃபர் அண்ட் குளோரினை கம்பேர் பண்ணும்போது this oxygen and fluorine have low electron affinity than sulfur and chlorine. Why? Because oxygen has small size and the 2p orbital is very compact, high electron density, so we cannot accommodate another electron very easily. So here this oxygen and fluorine have low electron affinity compared to sulfur and chlorine. So this is the anomalous behavior of these elements. Okay, now with respect to the electron affinity in a period, it increases, and in group it decreases. The same reason you have to write for the electronegativity also. For the electronegativity also you have to write. So last periodic property, it is electronegativity. So what is this electronegativity? The tendency of an atom in a molecule to attract the shared pair of electron towards itself is known as electronegativity. Okay, in your book they have given the graph. So period la electron affinity வந்து increase ஆகும், அதுக்கு ஒரு slope கொடுத்திருக்காங்க, straight line. Okay, and in group the electron affinity decreases, அதுக்கு ஒரு graph கொடுத்திருக்காங்க. You can see the graph in your book. And next one, electronegativity, the tendency of an atom in a molecule to attract the shared pair of electron towards itself. A shared pair of electron ஒரு atom தான் பக்கம் இழுத்துக்கிறது, அதனால வந்து என்னன்னா electronegativity. So the tendency of an atom in a molecule to attract the shared pair of electron towards itself. What is shared pair? நான் ஒரு எலக்ட்ரான் கொடுத்துருப்பேன், அவங்க ஒரு எலக்ட்ரான் கொடுத்து ஷேர் பண்ணியிருப்பாங்க, அந்த 2 எலக்ட்ரானையுமே நானே இழுத்துக்கிறேன். So that is known as electronegativity. So the tendency of an atom in a molecule to attract the shared pair of electron towards itself is known as what? Electronegativity. It is also expressed in kilojoule per mole, and we cannot easily determine this electronegativity. For that, some arbitrary values are given. Okay, arbitrary values are given. For hydrogen it is 2.1. Okay, for hydrogen it is 2.1, and oxygen it is 4.0. Some arbitrary values are given, and these arbitrary values are very much important for calculating the electronegativity. And then Pauling, he gave this method to calculate this electronegativity, that is xa minus xb is equal to 0.182. That is xa minus xb is equal to 0.182 root of EAB minus EAA star into EAB. Okay, EAA star into EAB. Okay, by this equation you can able to calculate the electronegativity of what? Some elements. Okay, for example some of the elements you can calculate the electronegativity using this equation. EAB, EAA and EAB are the bond dissociation energies of A and B. Okay, bond dissociation energies, they are the bond dissociation energies of A and B. They are the bond dissociation energies of A and B. And this electronegativity values or this electronegativity values are useful in determining the nature of bond. Okay, so this electronegativity values are useful in determining the nature of bond. So whether it is covalent or ionic or whether it is coordinate bond, that can be determined using this electronegativity values that you might have studied in 10th standard. Okay, so these electronegativity values, it is very much useful in determining the nature of bond. Now the electronegativity in period. Okay, So electronegativity in period, it increases. The same reason, since the electrons are added to the same shell, nuclear charge increases, the size decreases and the shielding effect decreases, so the electronegativity will increase in a period. Okay, for example, in period, the 15th group, the 15th in periods the electronegativity increases, whereas in group the electronegativity it decreases. For example, here the electrons are added to new shell and nuclear charge decreases, shielding effect increases, so the electronegativity in the group it decreases. Okay, electronegativity in the group it decreases. Okay, for example, here in group, halogens will have higher electronegativity, whereas here for electron affinity halogens will have higher electron affinity. Halogens have high electron affinity, high EA. Halogens have high electron affinity, and these noble gases have zero electron affinity. So noble gases la stable electronic configuration irukkaranala they have zero electron affinity. Noble gases la stable electronic configuration irukkaranala they have zero electron affinity. Similarly, 15th group la ullavanga they are highly electronegative. Halogens are highly electronegative. So in the 14th and 15th group they will have different anomalous behavior, increasing trend apart from the decreasing trend. Group la the 14th 15th group mattum enna agum, it will increase. Okay, group la electronegativity decrease ஆகும்னு பார்த்துருக்கோம். ஆனால் நம்ம பீரியாடிக் டேபிளில் அந்த 14th 15th group அதில் மட்டும் என்ன ஆகும்னா electronegativity it will increase. Okay, that is anomalous behavior. So valency is nothing but the combining capacity of an element, or it is the number of electron in the valence shell, or 8 minus the number of electron in the valence shell is the valency. So these are some other definitions for valency. Now this 15th group number of electron valence shell will be 5. So the valency will be 3 or 5, or their oxidation will be 3 or 5. So for this 15th group element, they will have variable oxidation state. Similarly, transition and inner transition elements will have variable oxidation state. Then in the left side of the periodic table, they will have low ionization energy. Low ionization energy irundha enna agum, they will be highly positive or highly electropositive. Easy electrons kudutanga it will have electropositive behavior, so they are metallic. Adukku appadiye opposite on the side. So in the right side they are all they have high ionization energy. So if they have high ionization energy, they are highly electronegative. So this is about the non-metallic nature in the right side. Okay, then there will be similarity in property when elements placed diagonally, that is known as diagonal relationship. Okay, so diagonal relationship, the similarity in property when elements are placed diagonally, it is known as diagonal relationship. So ஒரு elements diagonal-ஆ இருக்கும்போது அவங்களுக்கு ப்ராப்பர்ட்டிஸ் சிமிலராக இருக்கும். ஒரு பீரியடோ குரூப்போ இல்லாமல் சில எலமெண்ட்ஸ் diagonal-ஆ இருக்கும்போது they will have similar property. For example, lithium magnesium and beryllium aluminum. Okay, so diagonal-ஆ இப்படி இருக்கும்போது they will have similar property. Lithium magnesium, then beryllium aluminum, then boron silicon will have similar properties. So this is known as diagonal relationship. There will be similarity in properties when elements placed diagonally is known as what? Diagonal relationship. Okay, so this is an important concept in chemistry. Then some of the elements, like for example sodium when it reacts with oxygen, it forms what? Na2O. Okay, so it is a basic oxide. Sodium when reacts with oxygen, it forms Na2O. Okay, then chlorine when it reacts with oxygen, it forms Cl2O7. Okay, Cl2O7. So this is one important concept. So 2 and 2, here also 7, so it forms Cl2O7. So when the sodium oxide, when it is added with water or when it reacts with water, it forms 2 moles of sodium hydroxide. So when this sodium oxide, when it is treated with water, it forms sodium hydroxide. Then Cl2O7, when it is treated with water, it forms what? perchloric acid, HClO4, perchloric acid. So the sodium hydroxide is basic. So இது வந்து ஒரு basic oxide. அப்போ இங்க வந்து என்ன ஆயிரும் basic compound form ஆகும். And here it is acidic oxide, it forms acidic compound. So இது வந்து நமக்கு இந்த சைடு இருக்கும் இல்லையா? So இந்த பக்கம் mainly acids, right sideல, left sideல என்னவா இருப்பாங்க? பேசிக்கா இருப்பாங்க. Left side it will be basic and right side it will be acidic. And some of the elements in group, for example this beryllium hydroxide, okay, it is amphoteric. Okay, beryllium hydroxide is amphoteric and this magnesium hydroxide is weakly basic. இது வந்து weakly basic இருக்கும். Okay, magnesium hydroxide is weakly basic. Then our barium hydroxide, this barium hydroxide will also be more basic. Okay, barium hydroxide, it is more basic, weakly basic and more basic. Okay, beryllium hydroxide amphoteric, magnesium hydroxide weakly basic, and barium hydroxide it is more basic. Okay, more basic. Barium hydroxide is more basic. Now this beryllium hydroxide is amphoteric in the sense this beryllium hydroxide it exhibits the properties of both acid and base. So beryllium hydroxide வந்து amphoteric னு சொன்னேன். Amphoteric na what is the meaning na? It has both acidic and basic property. அதுல acidic and basic property ரெண்டுமே இருக்கும். It has both acidic and basic property. So the acidic and basic property we will give one example. For example, when this beryllium hydroxide, when it reacts with HCl, so beryllium hydroxide oda HCl போடும்போது it forms BeCl2. Okay, BeCl2 plus H2O. So the beryllium hydroxide oda நீங்க வந்து HCl போட்டீங்கன்னா it forms BeCl2 plus H2O. Okay, BeCl2 plus H2O. And similarly when beryllium hydroxide is treated with sodium hydroxide, that is NaOH, it forms the compounds like treated with sodium hydroxide, it forms Na2BeO2. Okay, Na2BeO2. Okay, Na2BeO2 plus H2O. Okay, Na2BeO2 plus our H2O compound, that is water is formed. So this BeCl2, this BeCl2 is what? BeCl2 is acidic since it reacts with acid, so it has an acidic property, and this beryllium hydroxide when it reacts with base it has basic property also. So these two equation it explains that beryllium hydroxide has both acidic as well as basic property, that it is amphoteric. So these are all some of the chemical properties or chemical trends, chemical periodic trends in our periodic table. So in this lesson we have learnt about lot of periodic property, the arrangement of elements in period, group. Okay, so all these things we have learnt in this lesson. Okay, now so for today's homework you learn and write the anomalous behavior of this electronegativity and electron affinity. Okay, so learn and write the anomalous behavior or the periodic property, that is electron affinity and electronegativity. So first one, periodic property, electron affinity and electronegativity. Okay, so electron affinity and electronegativity, not definition alone. So every variation in period, group, everything you have to write. Okay, electronegativity. So this is your assignment. So learn and write the periodic property, electron affinity and electronegativity, its variation in period and group. Its variation in period and group. Its variation in period and group. So I hope you have understood the today's class. Okay, so you do the assignment properly. So you do the assignment on that day itself. You write in the assignment note and send it to me, that date, and send it to me. You write the weekly test, unit test, everything without being absent for that classes. Okay, you attend the online class also properly. Most of the students are not attending the online class. Okay, you attend the online class also properly. I'm always there to check your assignment. Please do the assignment regularly. Thank you for listening to me. Thank you.